Hi, Allie. We are starting off today with an exponential growth problem that we haven't seen this kind of twist to. So if you would write it down, we have 2 hours. At 2 hours, 125 bacteria. And at 4 hours, 350. And we want to find the initial population. So we know how to use our equation for, say, the population, or we'll say the amount equals CE to the KT. But we aren't given K, and we aren't given the initial population, but we are given the amount at 2 different times. So I'd like you to fill in this information, the 2-hour information, into the formula and see what comes out, and then the 4-hour information into the formula. So Bailey, what's it look like when I start with this information?
So 125 equals CE to the K times 2.
Right. So we know time and we know the amount at time too. So notice these are much related. This is always the amount at this time, so there is a relationship there. All right, and so then we can't really solve that by itself because it has 2 unknowns. So let's go over to the 4-hour information. What would that look like?
350 equals K or CE to the K times 4.
All right, so that's not so bad. It's what to do algebraically after that. And the twist is you're going to solve, say, one of these for C and plug it in for the other one. And it's really not too bad. Let's solve this one for C. So if I want to get C by itself so that I can plug that expression in for C here, what would it look like? So Bailey, when I solve this for C, I get what?
125 divided by e to the K2.
Right. And I'll put 2K. So that is C. So C equals that. So I am going to take this expression and put it in for C, because C is the same on both of these problems. The initial population is the same. So I'm going to have 350 equals 125 over e to the 2k, 125 e to the 4k is on the numerator, and so I have 125 e to the 2k, e to the 4k. Now this is just some algebra, so what is e to the 4k divided by e to the 2k? Bailey?
E to the 2K.
Alright, so now we're making some progress. Just by subtracting exponents, we can combine those. So go ahead and take out your calculator and divide by 120. And what do we get?
2.8.
Right, 2.8 equals e to the 2k. So just finish that in our normal fashion. What will we do next, Bailey?
ln.
All right, so we end up with ln of 2.8 divided by 2. And that should be our k. So what do we get for k?
0.51.
All right, give me a couple decimals.
0.5148097.
0.5148. That sounds good. All right, now I want to take that information back into the original and finish the problem. So I'm going to put, I'll start up here. A equals, we still don't know the initial population, but we do know the K. But there's enough there now that we can finish it. So we need to put in numbers for A and T. Any suggestions since we're looking for C?
Well, T would be 0, right?
At this point, we don't know enough. We don't know the amount at time 0, so we can't use 0.
Okay.
Because we have to...
Oh, so we can plug in just either one of those
Yes,
two.
either one. That's what I want to emphasize.
Okay.
So which one you want to pick?
Let's just do 2 and 125.
Alright, so 125 equals CE to the 0.5148 times 2. And remember that connection. This is always connected in this, and this means at time 2, this amount is in our petri dish. All right, so I'll just let you go ahead and solve that. 125 divided by e to the 0.5148 times 2. Make sure there's some parentheses in there. And
Is it 44.6?
yeah, so we won't divide our bacteria in half. I'll just round it to 45. All right. All right, I just wanted to show you that kind because it does come up, and it really isn't any skill on here that you'd haven't seen. It's just that first step where you combined the two equations right here. So if you see that again, you'll know what to do. All right, we are going to put this exponential growth and decay to rest. Allie, I did show Bailey how to do one of those elements problems, decay of radon and carbon and all that. So I will show you that later. We didn't record that. So if you had trouble on that assignment, you can, I'll show you one before I put this up online. So also, Bailey, I collected by going to the copier and copying. I got differential equations number 8 and 10, and that was on section 6.2. The differential what was that? It was exponential growth problems in X and Y, number 21 to 24. The countries, Latvia and all that, 57 to 61. And the chemistry problems are on hold. I'll take those next time. So those are 34 to 39. And the visual handout on limits, I did collect. So if you would get a copy of those to me, I'd appreciate it. So hope you're feeling well enough to watch this and to catch up before next class. We're going on to a new topic, so find a spot in your book, and we're going to call it inverse functions. A little review of what an inverse function is. And let's see if we can recall something about them. See how well you were trained. Inverse functions. All right. So before we get to the calculus part, we have to remember a little bit about the algebra of inverse functions. And I'll just do a quick review. If you would jot as much down as you can on this, I'm not going to slow it down for that because I think it should be in your brain there somewhere. Let's look at an example of a function. Say f of x equals x cubed plus 1. And I taught you at one time how to algebraically find the inverse of that function. And the first thing we did is we called f of x y. Then we exchanged x with y. And we solved for the new y. And so we ended up with the cube root of x minus 1 equals y. So this is sometimes written as f to the minus 1, which is read f inverse. And we took probably a class or two during pre-calc to learn how to do that and practice it. All right, today I'm assuming that's still in your brain, so I'm not going to practice it, but I'm just going to mention it. So when you find the inverse of a function, you have to switch x and y and solve for the new y, basically. Do you recall how they appeared on a graph? Well, let's look at this example. X cubed plus 1 is sort of a, is this graph raised up 1, and x, the square root of x cubed, so a cube root of x minus 1 will look like, let's see, cube root goes like that. So minus 1, it would come down a little bit. So it would probably, I'm going to have to look at my graph when I did this. Oh yeah, that's right. It comes down here and then it flips up here. That's the cube root graph. And if you notice, and if you recall, these are reflections across this line. So if I was to fold the board along this blue line, I would see that this function will sit right on top of that function. And that's pretty much what I trained you last year. Do you remember that? Is that,
With
I don't have
like
to.
wax paper.
Yeah, we did do wax paper. I don't think it worked too well, but we
It
did
worked.
it. Okay. All right, so let's look at this one more thing before I leave the old and enter the new, is look at this function. If you could do what I just did for this function, I would like you to, and I'm going to write it on the board. Bailey, you just ignore me and try to do it on your own, Allie, and then look up. I want you to find the inverse function and try to graph it as well. All right, when you took switch the x and y, you ended up taking the square root of both sides. Just recall that that creates a plus and a minus on the other side. So you have two graphs to put on top of one another to get the graph of this inverse. I'm going to erase this one. So I put the graphs there. Try to beat me to it. See if you can graph y equals x squared and its inverse. Here's y equals x squared. And square root of x looks like this. And when we have a negative square root of x, it just reflects that around here. Alright, so what's the matter?
I tried to do it, but it looked really funny.
I forgot to time this. So what do you think we've been? Why don't we, after I finish this part, we'll start a second video.
Okay.
And I'll actually time it. My phone can do that. Alright. The thing about this function I wanted to point out is that this function's inverse is not a function. So look at the purple. It doesn't pass the vertical line test. So to do the problems that we have to do today, we must have functions, inverses that are functions. So if I gave you this one and asked you to do what I'm going to ask you to do later, you first have to check and see if the inverse is a function. So if it doesn't, just say no, it's not, we're not, and we're done. So I'm not going to do it. So, all right, so let's shut down this part one. I wasn't timing it. I don't know how long it is, so I'll be back in a second.
Bye, Allie.